So you can see my screen now?
Yeah, I can see.
Perfect. We see your
Also
screen.
advance your screen. Delete the left-hand side.
Okay, good. So now,
Okay,
Good.
yes. Perfect.
yes, okay, good.
You are
This is
presenting
the,
in the presentator mode, but it's okay.
that's right. Okay, so we have the 2025 Global Climate Review. I just wanted to focus on, in the year 2025, how does the climate looks like globally? Then I'll give a few, one or two examples from West Africa, and then we can have a discussion. Next time, if you want me to do Asia, I will do Asia. If you want me to do South America, I can do that one. Whichever region of the country, of the world, I can make a presentation on what is happening globally. So, so now the outline is we're looking at global temperature trends. What is happening globally: sea surface temperature, ocean heat content, ice and sea extent, hydrological extremes, heat waves, ecosystem stress, Africa-specific impacts, tipping point risks, greenhouse gas concentrations, impact of sea level rise, extreme weather events, issues relating to agriculture and food security. These are global perspectives. Then global climate inequalities, policy imperatives, data and monitoring needs, urban climate risk across the world, ocean systems and fisheries, energy and transition pathway. Then I'll give a few conclusions. Can you hear me very well?
Yeah.
Yeah.
Okay.
Now, so the first point is that 2025 is likely to be among the three warmest years on record.
Oh.
2022, 2023, 2024 were the two hottest years, and now 2025 would be the third hottest year. So the three hottest years in the world has occurred over the last 3 years. So there's persistent warming and it's not cooling. And now, for the past 3 years, we have exceeded the 1.5 degrees, which Paris Agreement has an objective that we should reach 1.5 by the year 2100. So we are 75 years away, and already we have already reached 1.5. So we have what we call overshooting. So we are now overshooting 1.5, which means that we have to have big emission reductions if we have to come to 1.5 or even 2 degrees by the year 2010.
It looks bad.
It looks bad. Now, this is the record since 1940. And then we can see that the yellow line is the 2023, and then the pink or the mauve line is 20, no, the orange line is 2024. So 2023 was the hottest year on record, followed by 2024. And now we are updated up to October this year. I don't have the November this year. So maybe in early December, I will get the November data. But whatever be the case, 2025 would be either the first, the second, or the third hottest year on record.
Yeah.
Now, this is the, if we take the 2025 as a projection of 2024, which means that the temperature prediction in 2025 will certainly be warmer than 1.5. We don't know what it will be like, but it's certainly going to be more than 1.5. And for sea surface temperatures globally, 71% of all the oceans in the world have a temperature which is higher than the global average, which is either the Pacific, the Indian Ocean, the Atlantic Ocean, and the Oceania, all of them are showing that they are 75% of the oceans are warming. Then there's what you call the marine heat is expanding in frequency and intensity. So the heat episodes are becoming more frequent and more intense than we have seen before. Then there's something we call the ocean heat content. How much heat is stored up in the oceans as a result of the continuous warming. And they are the key drivers of the long-term sea level rise. So when the ocean is warm, the sea temperature, I mean the volume of the sea becomes higher. You know, if you heat water or heat any liquid, the volume increases. So the oceans are increasing in volume, and they are causing sea level rise. And now also, we've seen that the deep ocean is warming. In fact, formerly we had already thought that it is the surface, the top 2 kilometers, which is warming. But now we've had evidence to show that deeper than 2 kilometers, the ocean is the deep ocean, which is also warming very fast.
What is going to happen with the Antarctic and the Arctic?
That is the next slide.
I
The
see.
sea ice extent. The Arctic winter extent is showing very low records of ice. And the Antarctica extent is persistently below average, which means that it is normally the sea ice at the Arctic and the Antarctic changes from year to year. But
Yeah.
to find the average, now consistently, we are getting below the average for both the Arctic and the Antarctica. And the cryosphere is beginning to be more unstable, meaning that big ice blocks are melting and falling into the sea.
Yeah.
And then the rainfall is also being affected. The hydrological cycle has changed. Extreme evaporation is taking place because of the heat, and it is causing severe drought. The atmosphere is becoming warmer, and intense rainfall and flooding is becoming more frequent. And we are beginning to see regional hotspots emerging. So in Africa, in South America, in Asia, in Europe, we are beginning to see that there are places where it's becoming very, very hot, higher than the average. And I will show some slides later too. So extreme heat is taking place. More frequent and longer heat waves have become the norm. The rising well bulb temperatures are going up, and this is having severe impact on health and productivity, particularly those with asthma and other upper respiratory problems are beginning to suffer more from the heat waves. The elderly and the younger people are also more vulnerable. Now we have the ecosystems. Between 2020 and 2025, there's a mass coral bleaching. 80% of the reefs globally are affected. And warm water biodiversity is collapsing the coral reefs, and other biological diversities which are embedded in the coral reefs are also declining. So now Africa specific. Africa is beginning to face a lot of erratic rainfall, and food security is becoming a problem. And areas where we used to have water, now we are getting little or no water. Please give me a second. My driver is calling. I'll just one slide. Yes, just one moment. Hello, Felix. Yes, I'm in a meeting. Are you able to talk to mommy? Oh, okay. Hold the line. I will let them pick the phone for mommy. Okay. Sam. Sam.
It looks like it's
Yes.
worse
Go ahead.
than we think. The
George
problem.
is
Oh,
a
yeah.
busy man, a busy man.
So
Okay,
you see that
yeah, go ahead.
there is. Okay, thank you. Thanks. Sorry for the break. So we have erratic rainfall across Africa, and food security is becoming a problem. Small rivers are drying up completely, and big rivers are showing very big decline in the fluvial flow.
Wow.
Coastal areas such as Accra, my city, Lagos, and Dar es Salaam are having serious coastal erosion. And like we discussed about 2 weeks ago, all the underground water is becoming saline. So when you make a well, you are getting more salty water. And sometimes they are more saltier than even the seawater. Now, then we have what you call a tipping point. And this is very, very crucial. When you have polar ice destabilization, when you have the polar ice declining, then there are very big, serious issues. For example, I wish if okay, I will try to explain. If we don't, if I cannot explain it well, next time I can show a few slides. You see, there are some ocean currents. For example, one that moves in North America along the coast from, let's say, Florida down to New York, then it goes to Montreal, Canada, and goes up to Iceland and to Greenland. Now, there is an ocean current which is now diverting, is taking heat instead of after getting to Montreal, the ocean current should cool. Now the ocean current, the hot one, is pushing beyond Montreal to the northern part of northeast of Canada, and this is warming the sea around green ice. And when that happens, then the ocean circulation belt begins to becomes weak. And we know that the ocean current is one of the drivers of the climate. So we are beginning to see that the ocean circulation is becoming very weak, which means that winters can be very, very long, or summers can be very long, depending on what happens in any one particular year. And the feedback, irreversible feedbacks, are beginning to be possible, because we've always thought that if we have warm or very cold Arctic winters, it will stay for only 1 or 2 years and then it will change. But now the feedback systems are becoming to be very weak and they are irreversible. Once it gets warming, it gets what? Then it becomes warming year after year after year. The mechanism for reversing that heat, it doesn't take place. So that is what we call the tipping point. And this is one of the most riskiest things we are beginning to see. That we go to a certain point and we cannot cool, the global temperature cannot go down anymore. It will start increasing. Let me try and explain one thing. Okay, let me go back. Now, what is happening is that the sea contains a lot of carbon dioxide. In fact, there's 10 times more carbon dioxide. No, in fact, about 100 times more carbon dioxide in the atmosphere, in the sea than in the atmosphere. Atmosphere has about, let's say, 4% or 4.5, 0.4.5%, 0.45%. Oceans have over 4.5 ppm, much higher than the air.
Yeah.
Now, when the oceans are beginning to be warm, then the amount of oxygen in the ocean begins to be less. Henry's law: the hotter the liquid, the less air it can dissolve. So this is happening in the oceans, and I will later explain the impact, maybe from a couple of slides down the line. So now, what is happening? Human activities, or anthropogenic effect, is causing an ever-increasing amount of atmospheric CO2, methane, and nitrous oxide at very high levels. every year is going up and up and down. There's no year where over the past 20 years where the amount of CO2 has gone down as a result of natural processes. During the COVID time, that was the first time in about 25 years that we saw amount of carbon dioxide in the atmosphere going lower than the previous year. And it's all because there was a shutdown for a couple of weeks or months. Businesses were down, planes were not flying, ships were not moving, people stayed indoor, they were not going to work. So emissions of greenhouse gases were low. But as soon as the COVID was over, emissions started rising again. Then the energy imbalance between the lower atmosphere and the high atmosphere is becoming very, very high. Okay. Now, as I think I was saying earlier, when we have thermal expansion, it is causing growing risk in low-lying areas, which means when the sea volume is high, then the wave causes erosion of the coastal, the sand on the sea. I mean the beaches. The beach begins to, the sea begins to take the beach, the sand at the beach away, which we call marine transgression. But the sea is moving more to the land and taking it. Then we have saltwater intrusion. As I said, when you have a well, and I'm sure Maria said it last week, that the salt water, even when you make a well, the well have also salt water. So the salt water is going in the aquifers and also in the rivers, which means that if you have a river which comes into the sea, because of thermal expansion, the sea is able to go a bit higher than the river because of the waves are coming, it's very strong and there's a lot of force. They go deeper into the river. So formerly, maybe in most rivers, maybe 3 kilometers, 4 kilometers is saline. So if you want to take the water for drinking water purposes, you go about 5 or 6, 7 kilometers and take the water. Now, in some areas in Ghana, the salty water had reached almost 10 kilometers. So the water treatment plants can no longer work. We don't have any mechanism to remove salt unless we do reverse osmosis, which is so expensive. So this is some of the issues which is beginning to happen all across the world. Then we have the extreme weather events. Cyclones, storms, floods are beginning to be very destructive. And I hear Thailand had 1 in 300-year floods. Just was it last week or last 2 weeks? Thailand had those high floods and a number of people died. So we have shift in the storm track. Even sometimes when you see a storm coming, let's say a hurricane coming, because of the thermodynamics of the ocean water, it may change course. So meteorology is having a lot of problems predicting where the next one would go, because we are having a lot of thermal energy in the sea. So it becomes very difficult how to track the storms, the tornadoes, the hurricanes, the typhoons are beginning to become difficult to track them. Then we have higher economic losses globally. Food crops, crops are dying. High intensity hurricane class 5 hurricanes, high cyclones, and the rest are causing a lot of economic damage. Roads are getting eroded. Coastal infrastructure is being destroyed. And I can give you some figures maybe next week or the time we meet again. I can give you what the cost is over the past 2 years, region by region. I cannot get country figures, but some countries I can get it in USA or Canada or maybe even Korea. Those with higher hydrological systems are able to give us good predictions of what the economic losses are. Oh, sorry. Okay, now agriculture. Climate variability is reducing yield. And you know, I read somewhere, but I have to cross-check whether this is true. I read in one of the scientific literatures that the global, what you call the global, let me put it this way, the temperature at which you have the highest crop yield is 16 degrees. If you have summer and winter, and the average is 16 degrees, then you can get optimal production. For every 1 degree increase, you have up to 5 to 10% loss. So if on the average, and the global average temperature is 14.5 all over the world, the average is 14.5. The Africa is, and the tropical areas are a bit higher, and the north and south hemispheres, the higher latitudes are a bit lower, but the global average is around 14.5. When we have 16 degrees, it's okay. Now, if your average now goes to 17, you can have up to 10% loss of agriculture production. If your average now goes to 18, you can have between 15 to 20% loss. So we are able to predict or project what will be the impact as a result of high temperatures. Not through the water stress, but also because of fungal and bacterial infections. We have a lot of pest infestation become higher with high humidity and high temperatures. Then the people who are most affected are the African small-scale farmers. They can lose a whole crop from 1 year to the other. 1 year it's very high yield. The following year, almost zero. Nothing. Then we have what we call the global inequalities. Now, the countries that are emitting less are now having a lot of impact. If we take Africa, for example, because I know the region very well, the global average of greenhouse gas per capita in Africa is less than 1 ton per capita. 1 ton per person a year. It's less than that. The global average, if we take the whole world, the global average is around 5.5 tons. And some countries, particularly the oil producing countries, United States and the rest, are having about between 18 to 25 tons per capita. So the countries that are emitting less are the ones that have big impact because of lack of safety systems. For example, there's no insurance, so small farmers don't have any insurance. When they lose a crop, that's all. They cannot replant again the following year because they don't have any money even to rework the farm in order to plant. And therefore, in the climate change architecture and negotiations, the issue of climate justice is becoming a very important part of the discussions. That the countries that are emitting less are those that are having the biggest impact. So countries that are financially well endowed should help those people who are emitting less and yet having the biggest impact. So we call it climate justice. Then we have what you call the policy imperative, is that we have to accelerate mitigation or reduction of emissions of greenhouse gases. But this is very difficult. Any country in the world, be it Africa, Asia, Latin America, North America, when an economy is developing, nobody wants to reduce the economic growth because of climate change. So the only thing we have to do is to get more money for adaptation. So as to adapt and then have technology transfer that is able to make us make our economic systems and social system more resilient to the impact of climate change. So we have to choose a policy that will help us. So now we have then, what do we do if we want to mitigate impact of climate change? Then we need to have a better climate services for planning purposes. Early warning systems are needed everywhere. So a few months before there's a major climate event, we should have predictions or early warning systems that will warn us that please prepare for more rainfall, prepare for more drought, prepare for more hurricanes, so that people can prepare well and not plant their crops when we know that they are going to fail. And then we don't warn them. Then when they have crop failure, then we have hunger and all kinds of social impact. Therefore, there is an increasing move or increasing call that the E3S, which is the European Climate Change Communicable Climate Center systems, together with WHO and national systems, should work together to help countries have better predictions of their climate systems. Now, then those of us who live in urban areas, and I'm sure all the four of us now are living in urban areas. Maybe Marisa, where you are living now is not a very big, you're not in a big city, isn't it?
Well, the place is about it's not just we're divided in departments, and where I live is maybe 3,000 people.
Okay.
I mean, 3,000, sorry, 300,000. But what we call the surrounding, the big area, it's up more than 1.5 million. Half of the people of the province is living in this area. So it's
yeah, see, so that if we are in a city, then we have what you call the island effect. We have more concrete works. Areas have been fully developed. When it's rainfall and high amount of rainfall, the water can't go anywhere because we have built roads, we have some small bridges, and flooding becomes a very big. So we are flooding become extreme. Then infrastructure stress is also a problem. The roads are getting eroded, bridges are breaking down.
Try to connect the.
Hello.
Akshat, try to connect to us.
To say something, I guess. She was connected.
Yeah, please, you can talk.
No, I think it was Daksha.
Okay, Daksha, okay.
No, it's fine. Yeah,
okay,
continue.
Good. Okay, good. So we have the ocean systems and fisheries. The oceans are warming and they are threatening fish stocks. As I said before, when the sea gets hot, the ability of the sea to what they call it, dissolve oxygen is less. So the dissolved oxygen, which I think we learned many years ago in Delft, that if you put organic matter into any water body, because of the BOD, biological oxygen demand, the bacterial activity of the waste will cause the oxygen to go low. And when oxygen goes low, then there's a lot of bad smell and so forth and so on. The same thing happens in the ocean. When the ocean gets hot, there's no pollution. There's no pollution in the sea, as deeper in the sea. Of course, there's plastic waste. But the sea is hot, and the hot water cannot contain oxygen. And if the oxygen content in the water goes in the sea goes below a certain level, some fishes will automatically die. Secondly, when the sea is warm, then the phytoplanktons in the sea cannot have optimal production. No, the zooplanktons cannot have optimal production. Then the phytoplanktons also have a problem because the zooplanktons are so low in their productivity, and therefore the fishes which feed on the phytoplanktons and the rest are also not having enough food to eat. So this is where the problem comes. And also there's something we call ocean acidification. When there's a lot of CO2 in the sea, then the sea begins to behave as if it's like a dilute carbonic acid. And therefore it is killing, the temperature and the acidity is killing the coral reefs. And that's also affecting fisheries. Then the mangroves are also affected. And therefore in West Africa, we have found that governance of mangrove systems are very important. And a lot of mangroves are beginning to see, mangrove restoration are beginning to get attention because some fishes breed, the early life cycle of a fish starts in the mangroves before they go into the sea or into the river. So these are some of the systems that are taking place, at least in West Africa. Energy transition. At the moment, we are producing between 50 to 52 gigatons of carbon dioxide into the atmosphere every year. And we need to produce, at least we need to release 35 tons. Now we've exceeded it by 35 gigatons per year. Now we've exceeded it by 15 gigatons. And therefore, we don't see any end to warming of the atmosphere. It will continue for years to come before we can reduce that those emissions. We are waiting for technology that will be able to use less energy per unit of production. So renewable energy expansion is very important. If we continue to depend on fossil fuel, warming will become higher and higher. And just transition for Africa will be very important because African systems are very weak. The socioeconomic systems, the farming systems, and then all the key systems are very weak. So people cannot change from one, if we have disaster 1 or 2 years, it takes a long time, 10 years or 8 years or 5 years before the community can come back to where they were before. So the issue of just transition is important. So in the end, the conclusion is that warming is systemic and persistent, and it is increasing. Impacts are multiplying across the world and across all sectors, and the world must come together to find a solution to these problems. Thank you very much, colleagues, so that we can discuss now.
The problem that the countries that produce more are the ones that are less favorable to reduce that thing, They
that
just,
is true.
United States has been going back to use coal in some places to heat, which is terrible. And, here in my country, in my area, which is very dry, it's a dry area, we are moving a lot. Most of our energy is produced by is hydro energy. We have the rivers and the dams and everything, and now we're moving to the solar energy, and a little more up in the north of Argentina or the south of Argentina, they are starting to use wind, energy. But here in my area, we are getting a lot of solar energy every year more. But we don't know what's going to happen, because sometimes I say that if you have, I wonder what's going to happen in the beginning after 20 years or 25 years when those solar panels are not useful, and that we are going to have a lot of garbage. But they say that it's not so bad. But we are moving to renewable energies, really. In this area, all the west area of Argentina, most of the energy is produced by dams and rivers, and now they are moving to, like I say, the wind energy and the solar energy. It's the east of the country and the central part of the country that are still using fossil energy to produce energy, basically oil, because we have enough oil, and now there's a lot of gas also, so they are trying to use that one too. We have only two plants, maybe 2 or 3. I don't remember if this one working of I call it the energy with uranium, and we have uranium here in my area. So, but there is a big the people is afraid of that. They don't want to. But I still think there is one of the less problem with the uranium energy than with other energy like the coal or the oil.
That's correct.
Hey,
I
George.
don't know.
Yes.
If you allow me, I'm happy with the presentation, and
Yeah.
I have a few points I would like to stress. If
Sure.
you please put your slide number 18. Start with your 18. Go back to your 18.
Okay.
Slide number 18.
Okay. Slide number
18.
18.
Well, you have
With the arrows, it would be easy. Okay, that's the 18. Good. The problem, I think the problem is for us, the poorest countries and the not the high emitting. We are
Yes.
low emitting regions. In Bolivia,
Yes.
we have a special problem. I wrote it for the Swiss cooperation to the
Yes.
Bolivian universities, and it's called the Climate Agenda. And it was
Yes.
well conducted. It had three phases. The first and the second were completely done, and it were good. They were good. The name is adaptation.
Yes.
We cannot fight against the climate change, because it depends on the developed countries, not underdeveloped countries. Okay, we have to
Yes.
adapt, and the name for that adaptation is resilience. We have to
Yes.
trust our
The-
resilience. Someday,
Yes.
maybe I would try to present the results of these two
Sure.
stages. It took almost 10
Mhm.
years to work with that. Well, we have to have resilience. We have used resilience in the Andean part of Bolivia. And now in the phase three, we are moving to the tropical part of Bolivia, which is the largest part. Bolivia is known as a high level country, altiplano.
Yeah.
That's not true
Yes.
because Bolivia is 67% tropics. Okay, we are
Hmm.
tropical country,
Yeah.
not really high altitude. People lives in the high altitude, but we have nice forests and everything. That's why we are working with Bella in this project, dealing with the Bolivian and the tropical rivers with the Amazon rivers. And of
Yes.
course, Amazon, I'm checking some data I was taking,
Yes.
is the largest basin in the world.
Hmm.
Amazon covers 7 million square kilometers, more or less.
That's
No?
yes. That's correct.
It means 40% of South America is the Amazon basin. And what's
That's
going
correct.
on? It's the Amazon is drying. In
Hmm.
Colombia, the meeting point between Colombia and the Amazon River is called Leticia. Talking with
Hmm.
people from Leticia in our research, they told us we are crossing the Leticia to go to the other side walking because there is no water. Can you imagine?
Hmm. Yeah.
Not
Yeah.
only
My
we
question.
have a water shortage,
Yeah.
but also we are polluting our water, and that's the point we are
Hmm.
working with Bella. We are interested
Hmm.
in mercury pollution because with
Hmm.
mercury we're killing our fishes and other things. So the problem is quite large. And it's not
It is.
a big problem from for the Americans or the Chinese because they wanted to continue polluting the air, increasing the CO2 concentration. Doesn't matter. Even Mr. Trump, he doesn't trust in the climate change. That USA didn't attend the COP30 meeting. They didn't
Yeah.
attend the COP3 meeting. They sent some delegates, but Mr. Trump didn't attend the conference in Belém because they are not interested in that. They are interested
Yeah.
in money, as we talked last Sunday with you, George. What they
Yeah.
want to talk about is money, and that's it.
Yes.
They don't care about the impacts. But they
No.
are suffering impacts. They have
Of course.
huge climate change effects. Those terrible, terrible
Beautiful.
changes are felt in USA, but the government doesn't want to link it to climate change.
Yeah.
They are
Yeah.
interested in other topics, no? That's why
You see.
I will point to your presentation that the main problem is for us, for low emitting regions, no,
Yeah.
and we have to adapt to that. It's
In fact, I can make
the amount of
presentation.
water in the Amazon is the
Yeah.
lowest in 120 years.
Yeah,
In
it's true. It's true.
120 years, that the water is lowing, 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 lowing. And the
Yeah.
effects, of course, are great against the people. No? Brazil, Colombia, Peru, Bolivia are suffering a lot. The dredge. No, we have a shortage in electrical energy, of course, and we have flooding also in our cities are growing. In the underdeveloped countries, people from the rural areas are moving to the
Goes to
cities,
the cities.
and the amount of people, for instance, Cochabamba in my young days were 200,000 people. Now we are near 2 million people, and the
Yeah.
amount of people is great. And we have a shortage of water, we have a shortage in electrical energy, uh, and
That is true.
the environmental pollution. So the
Pollution.
problem is huge. Really, climate change is
No,
a
it's a
tremendous thing.
big problem.
That's
It's
why
a big, big
we are
problem.
talking with Bella that we should join in our project not only
Yes.
mercury pollution in the Amazonian waters in Bolivia,
Mm-hmm.
because it will continue with Brazil also in the second phase, but we have to join with the uh, with the global warming. Okay? We are
Woman.
going to
Yeah.
join the global warming because it's affecting. No? Global warming and mercury pollution are problems that we should take into account at the same time. Not one project there and the other project there. We have to join efforts and to start studying. What I am feeling is that I am 81 years old and I will not have time enough to see what's going
Yeah.
on. But I'm
Going
working
on.
with young people, and
People.
I am just lecturing
Mm.
whenever I can
Okay.
about this topic. So this topic
Oh,
is quite important,
but,
George,
yeah. Yeah.
and
You see, what I
you are
gave is,
good with that. Maybe in some
yeah.
other moment we will can discuss a possibility of bringing you here also. Not only Bella, but I would like to bring you George and whoever takes care, Daksha and
Okay,
Yi
thanks
and
very much for the
every because it's
very nice
completely okay.
Yeah.
explanation.
Yeah.
Bringing George
I
will be
have, I,
will be
I have
Time
one
for
easier.
me
question
to go
for,
bed.
Yeah,
I have one
Okay,
question
goodbye. See
for
you next
Yi.
week.
Yi, I have one question for you. So you listen to my question before you go.
yeah. He went already.
Yeah.
He's sleepy.
Oh, oh, okay. Then next time I'll put it down because Korea is doing a lot on solar energy. In fact, the
Mm.
solar energy potential of Korea is among the highest in the Asian region.
Yeah.
They're doing
Yeah.
photovoltaics. They are doing wind power production from offshore and onshore. Korea has
Mm.
got wind farms, and they also have biomass and waste to energy systems. They are burning their waste in order to generate electricity. Now, I want to know what is the current program of Korea to reach what you call the zero emission. As much emission as Korea emits, they also have systems that remove that same amount from the atmosphere, or from improving energy efficiency. So it is not that we shouldn't produce greenhouse gases, but we should have systems that will also absorb as much as we produce.
Oh, okay.
And yes, so maybe I will send the mail to Yi, so that if you can give us experience of how Korea is doing it, because Korea is emitting about 15 tons per capita. Bolivia is around 1.59 tons per capita. Argentina is 1.9. India is 1.49. And Ghana is 0.5 tons per capita. So I'll be interested in seeing the efforts in the Korean climate agency to address it. And also, Maria, you were right. Now, increasingly, nuclear energy can contribute about 30% of global electricity production if that is exploited to the maximum. So there's opportunity for nuclear energy, although it has its environmental impacts, but then it can be addressed. I mean, the issue is nuclear waste and minimizing nuclear accidents, but that can also be addressed.
You are referring to mainly to nuclear fission. I am hoping that we will have nuclear fusion, which is completely different.
That would be fantastic.
They are working on that.
All our greenhouse will be solved.
So nuclear fusion is the solution. Nuclear fission is helping to control global emissions and so on, but it's too dangerous. So we have to also suspect that we will be running with the nuclear
Everything
fusion.
is dangerous if you don't take the proper measures to control that.
Yeah.
Because that's the problem, basically.
Yeah.
Here we are getting less water every year, because we don't have snow in the mountains, like we used to. So our dams are going down. So hydro energy is not, I don't know how long it's going to be the highest production, but, they are having problems sometimes.
Yeah.
Not enough water.
In one of the meetings with the IHC authorities regarding our project, because we are trying to deal with it, I expressed also that the name of our IHC institution, it was International Institute for Hydraulic and Environmental. Remember, the name environmental was there. Now IIT has erased the environmental name. It's the International Institute for Water Engineering. So people are thinking in water, but they are not thinking in environment, because water is a part of the environment, but it's linked completely to environmental issues as we see. No? So we have to recover the sense. And Bella will discuss with us next week, presenting some material about his visit to Bolivia. He has a very beautiful model, a very beautiful, really, it's an innovative definition and concept of ecology. Ecology is not anymore just science. He speaks the scene biology, and he speaks the scene phenotypes and the ecology. He has something beautiful that I will ask Bella to prepare it to tell us, because this is not just water problems or climate change problems. Everything is changed. And in the middle are we, the humans, of course, and we should then recover the original idea of dealing environment. Remember, environmental issues were started to be discussed in Stockholm in Sweden in the year 1972. That was the first conference, and the environmental issues started. But now it seems that everything is being discussed apart, and there are not meeting points. And that's a very beautiful topic to continue discussing. Thank you, Vera. I think the time has been overcome. That's why he is in bed again. Hopefully next Sunday we can continue. Are you going to be available, George?
No, next Sunday I will. In 2 weeks' time, yes, I will be available. But next Sunday, I can prepare a presentation. But I think Alvaro, you are good in all areas. I can make a presentation on. Maybe we can choose the climate issues in South America, the issues, for example, the issue of adaptation, because I think that's where your main concern is, because the big polluters are continuing to pollute. They don't care what is happening, whether Argentina will die or Bolivia will die or Ghana will die. It's none of their problem. Trump wants to emit and emit and emit.
Good.
What can we do?
Okay. Should be nice if you can prepare it, let's say, not for next week because it's too short. Maybe in 2 weeks' time you can prepare something about climate change in South America, because you are completely linked to the topic. Maybe in 2 weeks.
Yeah. No, I can do within a week. It doesn't matter. If I get 4 or 5 hours, I know where all the databases are in Germany, in Japan, in Britain. We have the climate scenarios, we have those ones. If you want it, but I will not be available, but I can do it. If there's something else you can discuss, then maybe in 2 weeks' time I can make the presentation. But I can do it within a couple of, maximum 1 day, I should be able to finish that one.
Okay. Will be nice then.
Yeah.
And then we can refer also to India and some other places, separate, because the conditions and the problems are, although they should be similar, they are quite different. No? The South American circumstances. And in South America also, what happens in the Amazonian basin is completely different to what's going on in the southern part, in the Rio de la Plata. No? The conditions are completely different in environmentally point of view.
Exactly.
And climate change involves everything. So the main topic is climate change, because it refers to everything, even the war, the burning our trees and everything is terrible problem. Okay.
Terrible problem. Yeah.
Good.
So I will try and do something, and then share it with all of us. Oh, Daksha, it's nice to see you. I haven't seen Daksha for quite a while, but I hope she's doing well.
I've been listening to you. Very nice presentation.
Thank you so much.
But
Daksha, maybe you can tell us something about India for sure.
Every region has got its own problem.
That's right.
If you can't reverse the process of climate change, you have to look for adaptation.
Yeah,
that's correct.
And in every respect, be it energy, be it agriculture, be it everything.
No, you are right. Right. In fact, there is a new issue which has come up in the climate change, which is beginning to attract a lot of attention. We call it loss and damage. You see, when you have adaptation, there's a limit to which you can adapt.
Yeah.
And beyond adaptation, we have what you call autonomous adaptation. You adapt this incrementally, small. But an event happens, like major floods or major hurricanes, or you cannot adapt.
There's nothing you can do.
Yeah, you can't adapt. You have to be prepared for all kinds of damages it is going to cause.
Yes. So there is a fund they created about 2 years ago called Loss and Damage Fund.
Yeah.
And the effort is for developing countries to push hard for the developed countries, and we want to put even part of the money on Article 6, which is talking about joint mitigation efforts, some mitigation actions. And when you sell the carbon, then a certain percentage taken and put into this fund. But the developed countries are resisting it. But we can talk about that also, because loss and damage is very important. One of the solutions to adaptation.
Yeah.
So
You
I will
need
try.
money for
It
that.
has also some scales. Okay, you can
That's correct.
adapt up to some limit. You have
That's
a
correct.
limit to adapt, no
Limit.
more than that.
Yeah.
And
Yeah.
climate
Yeah.
change,
That's
we are not. We should not be able to put a limit. It can go indefinitely until we kill everybody. So
Yes.
that's not a problem we can deal with this kind of discussions, because
Yeah.
the climate change goes and it's not under control. The adaptation, yes, that's something
Yeah,
we
but you
can
have a
discuss,
limit.
but with the
Yeah.
limit, we have a limit
Yeah.
for that.
Yeah. True.
We can adapt to this limit, no more than that. No.
No more than that. Yes. And
Yeah.
beyond it, we cannot adapt.
Good.
Okay.
Okay,
So
guys, I have to leave you for today.
Thank you very much.
And
I
I
will
see
try
you.
to
Thank you,
edit
Thank
George.
it
you.
It's very nice. I will look it again.
and see you next Sunday, hopefully.
Bye,
thank you.
guys.
Bye
Yeah.
bye.
Bye bye.
Thanks and bye.
Bye bye.
Bye.
Bye bye.